Okay, let's make a start. So yeah, I'm James. I look after a team of cloud solution architects. Our job is to make cloud easier for Google Cloud customers through building repeatable technical solutions.
Yeah. And hi, I'm Leah. I'm the director of product for software foundations at Google. That's our internal developer platform. And I work in an area at Google called Core, where from a platform engineering perspective, we support all of Google's product areas, including cloud, but also GOL. You can see them all here. And we partner with Google Cloud on platform engineering. Platform engineering is a topic that's near and dear to both of us, and together, Google Cloud helps us to re-envision and reimagine how we can do platform engineering. And together, we package up Google's internal engineering capabilities and make them usable for cloud customers.
And it's not always obvious, like, even from this slide, like the sort of layer cake that happens in sort of large environments. So, my team consumes stuff from the internal core teams. That then goes to make sort of cloud products. We then give that to customers. Then we give advice to customers on how they build their own stuff on top. So it's just kind of turtles all the way down for these pieces. So there's a lot to unpack here, but it's fun.
So we have a lot in common when it comes to platform engineering, and it starts with we have the same business goal, and it's really useful. We're going to keep coming back to this basic business goal to maximize value with existing resources, today's resources, to get with acceptable quality and sustainable costs. Simple, easier said than done.
So before someone starts like shouting at me that that's not their business goal, this is more of a guide. So, but what this describes is the reason that we do these things, the reason that I talk to my customers about platforms all the time is because they solve business problems, right? That is the root of it. So it might not be you or your boss or your boss's boss, but someone is thinking about approximately this slide. And so, think about these problems, even though they're not, say, planet scale problems, think about them through some of these lenses, and we'll explore that today. So what are some of the problems? And here's a few examples of those kind of things. And I'm pretty confident, like, if you haven't seen all of these, you've probably seen one of these at some point, right? Like, hey, I've gone and done something, and then this other thing occurred, and this other thing occurred, and we're in this endless space of these sort of similar challenges. And as much as we like it, like throwing money at these or adding people to them doesn't always resolve these problems. Or if it does, it only does it for a particular time. So we're still trying to solve some of these problems that we have. Thoughts on that?
And no matter how successful we are, we keep having roughly these problems. So the trick in platform engineering and in our time together is really to figure out how we can find better and better ways to work with the system and not against it. So we get local decisions and team-level decisions that are in harmony as best as possible with our larger goals. So we have the same goals at some level on the business side, and we have the same practical challenges. Like we just talked about, we have a lot of different resources when we come to looking at the opportunities and challenges of platform engineering. You're going to have different tools, you're going to have different libraries, you're going to have different culture. All of these make up the different things that you have available to work with, and that's where we kind of get to this reality that although we have a lot in common, there's no one-size-fits-all solution. We just want to increase the value of the resources we have available at any given time, and that'll give us new clues about how to get better resources over time.
So enough of the MBA stuff. I know that's fun for some of you, but not for everyone. If you haven't seen this sort of concept before, like I think you're probably familiar with it in some form or another, right? We've all been, I think, spending time trying to improve software delivery. We've been doing that a lot by shifting left. If you haven't, give it a try. Like, it's pretty fun. That means moving more capabilities into the hands of our developers, allowing them to sort of tackle stuff earlier in the life cycle. And I think a good reminder here, I've been reminded by a few people today, like DevOps isn't really dead, right? Like, we've just adopted a lot of these capabilities. We're doing these things. If this is working for you today, you keep doing it, right? Like, that's great. Like, just keep doing some of these development activities. What have we found, though? I think we found a lot of teams overloaded. There's a huge amount of extra complexity that's coming onto our developers. We're constantly trying to deal with these issues sort of in the same way each time, and that's getting overwhelming, right? So we're seeing this sort of overwhelming pressure on our development teams in these spaces, and that gets so much worse at scale. So DevOps at scale just doesn't support some of these capabilities, and we need to think about maybe doing that in a different way.
Yeah, one of the things that happens when we shift left, we can do a great job of catching things earlier and taking less time to do all the things that a developer is responsible for. Developers still have a lot of responsibility and are still in the loop, and it's like shifting left gives us just room to ask developers to do more. So shift down is our platform engineering strategy, both within Google and for Google Cloud customers. We want to find ways to systematically eliminate responsibilities that developers have to be in the loop for and build them into the platform where we can. This allows us to not only free up more capacity, you can see on the right, there's just a lot more space for feature development on a given team. It also gives us the ability to have controls and influence over some of the things that matter for our business goal. And that really comes down to understanding quality attributes and what we do about them. When you look at the shift left landscape overall, there's so many different ways you could possibly eliminate toil or help out. This focus on quality attributes and how we can control them it's been a really, really clarifying and helpful and practical insight. So let's talk about quality attributes for a minute.
And like, you've heard of these before, right? So before you're like, quality attributes, what are you doing in the ivory tower? Like, these are non-functional requirements, right? Like, you might have heard there was NFRs before, but like, if you're not dealing with performance problems or reliability problems in platforms, let me know, because I want to work for you. Like, this is a fantastic, that'd be great. But no, like, these are the things that you build platforms for in many cases, right? And this list, it's not exhaustive either, right? There's a big and others in this space. So, these are the things that you're trying to tackle when you do a lot of platform building, and they're not stuff that you can just buy. You can't just buy 10 units of security. Like, oh, we need more security, 20 units, get me more security in the truck. Like, you can't do these things. They're a feature of your architecture, they're a feature of your platforms, not a feature that you put into your pipelines in these spaces. So have a think about the context that these occur for you and your list of quality attributes, but this is what we mean by them.
Yeah, and we focus on them for two reasons. First, if you look at this list, you'll see this is where a lot of the business risk resides in our software, the stuff that we really need to control. And they are fundamentally tied to architecture in a way that features aren't. They're like, for example, imagine you want to build a small feature like a user profile. And you could build that profile into like almost any architecture, whether you have a giant monorepo or a small collection of services. But if you think about how fast that profile loads or how secure the data is, those quality attributes about it, you can't just add those on the way you can add on another feature. They're fundamentally tied to the architecture. And in platform engineering, it's kind of helpful that we have this concept of quality attributes being really associated with a lot of like the risk that we have and the value we can provide, and they're fundamentally tied to architecture. That's something we want to take care of from a central point of view. Okay, so if we want to have controls over quality attributes and we care about architecture, where do we look? What tools do we have? In our experience, we're finding that looking at the lens of these two fundamental tools that we have for our platform and ecosystem design are super helpful. First, we have abstractions. You can think of those as like the resources that are available to you today, whether it's libraries or managed services or APIs. These give you the reusable components, the well-defined parts. Helps with understandability, it helps with reuse. They're kind of like the nouns of the system. And then we also have coupling, and coupling is the thing that kind of helps you make the best use of the resources that you have available at any given time. It's how the pieces of your system are interconnected. It's your policies. It's your dependencies. Coupling is what you can use to really get the most out of the resources that you have today. You can run more software on the same hardware, for example. You can go faster with the same resources. So coupling gives you a great amount of potential to make the whole that's greater than the sum of the parts. You could probably also make a whole that's less than the sum of its parts.
He doesn't like Legos, like Legos.
And so we use coupling to get great economies of scale. Early in my time at Google, I asked the question, how do you define an ecosystem? And one engineer that had been there quite a while, just off the cuff, said, an ecosystem is anything with economies of scale and tragedy of the commons. That really stuck with me. That was really on point. And so we use shared fate. Shared fate is a deliberate design principle in our ecosystems. We use it to get great efficiency. We use it to get velocity. But the flip side of shared fate and economies of scale is tragedy of the commons, meaning, everything is interconnected. So, for example, imagine you had a large-scale, global, continuous integration system. We actually have one of those at Google. It's amazing. You can get global, low-latency, high-quality correctness signals. Who doesn't want that? We build our system to have that, but a single developer on any team has the incentive to ship a little bit less correct code just a little bit faster to kind of optimize for local velocity. And that can accumulate and weaken the global quality signal overall. And then you have a bigger problem on your hands when something breaks and all the reverse dependencies are affected. So we need shared responsibility models, we need policies, culture, social practices that help us to get all the upside of economies of scale and really try to limit the downside of tragedy of the commons.
Developers cutting corners. That doesn't. Not my developers. So cool theory, really. Like this is, I see what you guys are doing at Google with the theories. That sounds fantastic, right? But this is just describing, it's providing some taxonomy for a lot of the things that you see in the outside. Like, this isn't my model. This is the NIST model. They're pretty good at this stuff. Like the idea of maybe demarking out different cloud environments into, say, IaaS, PaaS, SaaS. Hopefully this isn't a shock to a lot of people. I think people have probably seen those concepts before, but the idea of a shared responsibility model here isn't necessarily new. This is a good example to see some practical pieces of those abstractions, the quality attributes. When we talk about security, you can see how the quality attribute sits in these layers for these pieces. When we talk about a coupled service, something's coupled together. You're like, okay, sounds good. Well, if you have a Kubernetes cluster, you have GKE on Google Cloud. That's in the PaaS piece here. We're taking on that blue piece for you. That's the whole idea of building that. You can go and build all those sections yourself from the Lego blocks, but we've decided to couple that, provide you that capability. That's the practical, tangible example of what's happening in these spaces. But then think about the security pieces. Think about the network security element. We've taken on the networking for that. You don't have to go rack a switch. That thing is being done for you. You still need to set firewall rules. We can't think of the firewall rules for you. You'll still need to specify them and understand what they are. So the responsibility doesn't go away. Some of those pieces still exist. But think about this on those practical terms. This is what's already happening in your environment. So you're already seeing these kind of pieces. Let's wrap up, I think, a couple of pieces here, too. There's a lot of different bits, but it all comes into these same core things. And this is why we keep talking about things like socio-technical. Mm-hmm. Take the technical toolbox pieces. Use those things that you're using for consuming platforms or platforms that you're being provided are doing it this way. Understand the technical pieces. Add on the social toolbox. Add on some of those social toolbox pieces to understand what the right level of shared fate is, or the sort of responsibility model in those spaces. That's your whole socio-technical toolbox for this, all wrapped together. Fun.
So another practical consideration is how much platform and how much shift down should you have? How much is feasible, and is it worth it? Inside Google, I have to look across a large number of different types of businesses and different types of platform needs. There is no one-size-fits-all solution. So we've actually developed this map. This is like a map or a model to help us kind of figure out where our challenges are and where our opportunities are. So let me just walk you through the map really quick. So on the y-axis, we have the penalty for failure, basically. Like how bad is it if somebody makes a mistake, and how well will we notice if someone makes a mistake? On the x-axis, we have our ability to use our platform to gain control over quality attributes. On the upper left, we have basically the failure zone, like how, if teams are operating here, we have a risk of manual mistakes causing meaningful business impact, more business impact than we would like to have. And on the lower right, we have what we call internally the broccoli zone. And this is where our coupling, our processes, our tools become overly burdensome and slow developers down for the task at hand.
And the broccoli piece, it's a bit of a joke, right? It is a bit of a joke, but this is why I wear this T-shirt to a lot of conversations, right? And you can Google this. We did post that externally, but if you are an internal developer and you just want to serve 5 terabytes on an internal system, you're in that broccoli zone, and it's very frustrating. So it's not all magical, right? It's fantastic if I want to get something in search or maps, that's great. But if I want to get something just simply done internally, still got that broccoli frustration, right? So it's nothing about the actual vegetable, that's great. It's all about this meme that we've had internally to say, we're not always doing a good job in our ecosystem management, and we need to get better.
Yeah, getting better at getting better. So we keep coming back to that. And even if we're doing a good job, new problems are going to come up. OK, so when problems come up, which they do every day, it's kind of, you can usually tell if the problem exists in the human error risk zone or the broccoli zone. You'll know it by the type of concern or complaint you're getting. So that's not too hard. What is harder is determining where in this sweet spot, the ecosystem effectiveness zone, we actually want to be. This is definitely not a maturity model, because, for example, if you're all the way in a type 4 ecosystem, and we'll talk about this, you're going to have a lot of broccoli problems, probably way more broccoli problems than your leadership or your developers want you to be having. But these types help. We found that within this ecosystem zone, we can actually develop a pretty good understanding of what these different zones are. They have different shared responsibility models. You focus on developers in a different way. They give you advantages in a different way. They manage and deal with and interface with complexity in different ways, different enough that we can kind of distinguish and reason about where we're heading. And so we can use this map to go, OK, do we all agree on where the problem is? And then it's almost guaranteed when you begin a conversation about where the solution is, you're going to find that the answers lie across different types. And that's a really good thing to get clear on first. Who does the work? How much control is needed? How much risk can you tolerate? These are really basic, practical questions that actually give us insights about how to drive our roadmaps and priorities.
And have a think about where these occur in your own environments, right? And so this is just a model. So don't go back and be like, I've got a 2.1, and the Google, they said 2 was, but you can have 2.7, 2.12. I don't mind. Think about where they are, why you have type 1s, why are your developers doing shadow IT, or shadow AI now, I guess we're doing. What's happening in that space that they want that ability to control, and is it okay, right? Are they doing it with critical services or less critical services? Is it all right in some of this scenarios? Why do we always end up at type 2? I'm constantly asking that question. So think about why you want to be where you are in those spaces, not the specific things themselves, but we'll walk through more of that. The trade-off piece for that, I think, is also where we often have that conversation. And this is something we're going to explore a bit more going forward, but But think about also the trade-off here as not being, say, velocity. Like all of these can be high velocity. We have high velocity changes in type 4 ecosystems. That's absolutely fine. The efficiency of that, scalability of that, though, is different from the flexibility. Like if I want to do something, in a completely different way, I'm locked into that platform in that space. So think about these trade-offs not as like how fast can I go, but it's the other quality attributes that we're talking about in this space for those things. So think about these trade-offs.
So let's talk in a little more detail about these ecosystem types. We've found them to be pretty enlightening. And I think we're going to focus on the types 2 through 4 because that's where the real challenge and value of platform engineering ends up being. Those are the types of ecosystems that you're going to need when you're managing large-scale enterprise software or getting to the point where you might become large-scale enterprise software. So for each type, we'll go through kind of the mental model, how the shared responsibility, what looks different in general, and then to make it a little more concrete, like an example of application architecture that you might use just to kind of illustrate the point. So a type 2 ecosystem, the main thing to know here is the way it looks is that there's a lot on the development teams. It's actually really challenging to have reliable global enforcement of policies. So the development teams are really you build it, you run it here. Developers are in the loop for everything, including decisions and implementations. You might have specialists emerging on the scene, specialists like SRE teams, security teams, probably focusing on really targeted areas, either specific risks for your business or specific product areas. And from a platform engineering point of view, the biggest lever you have is probably working on making the developer workflow smoother, just removing toil, just focusing on that workflow, because developers are doing everything, pretty much. And so, yeah, that's sort of the model. You can see that it's the global decision-making is not quite in place.
And so that was the sort of the sort of developer in, but think about the platform up maybe in this model here. And this isn't, again, designed to be prescriptive. Don't just go build this at home. I mean, you can, but it's not intended for that purpose, right? It's designed to illustrate some of these pieces. And think about in some of these areas where the red X's here aren't, it's not a problem, right? The idea is that they are missing, so they need to be catered for elsewhere. So things like CI/CD is now delegated to your developer teams. That might be good, right? This might be what you want. We have a lot of cloud customers who come to cloud and they're like, I kind of want more freedom, right? I don't like my infra teams. I want to just use cloud and I want to just spin up what I want. And we're like, okay, I mean, yes, you can. And as long as you've taken that responsibility and it matches what you're aiming to do and the responsibility you need, you're in a good space for these. This isn't actually a problem type. What tends to happen, though, is sometimes that starts out that way, and then people realize, oh, I actually am in a different scenario. Think about the earlier chart. I maybe need to move up to think about a type 3, because I've got so many pipelines. There's Jenkins everywhere. So how do I think okay, this was good for a while, but it starts to scale up, and suddenly that's not okay. So think about this as not a bad thing, but why you would want to have this is for the flexibility of it, but you may want to think about type 3.
Yeah, and it's definitely the right platform type for many, many business problems, including ones that we have internally at Google. So type 3 is really where you end up being a lot of the time when you have really large scale software, enterprise software. It's you build it, you run it. It's your architecture is your cost. We've developed as an industry a pretty good working knowledge of how this works. Global policy and management decisions are effective through our shared responsibility model, through a lot of management, and development teams then become more responsible for the implementation, but not necessarily setting the policy. You probably have specialist teams like security teams, like UX teams, or internationalization, or
mainly
performance teams, but mainly security teams, helping to set policy and then providing guidance on what the definition of done is, what good looks like. So developers are still really in the loop for implementation and responsible for implementation, but with a strong leadership advisory mechanisms in place, so you kind of know what you're shooting for. And from a platform point of view, you probably have a much clearer bar for quality across your product areas here, and lots of help to achieve that quality bar. So you're not just focusing on the developer experience, but you're also focusing on what they're up against and how to help them with frameworks and better abstractions and more libraries and kind of all the tools they need to really be successful for the bar that the leadership team and the business is able to articulate.
Have a think about some of these differences, right? And I'm not going to show you this slide by slide, but like think about, you saw some of the red squares before, right? Like those are the things that tend to get filled in these scenarios. Some things haven't changed, right? One of my favorites is people are like, well, we always have optionality in all these things. I'm like, your identity team doesn't believe that. Like, hands up here who gets to choose their own identity provider. Anyone? No? We're not having it. So that bit's already fixed in these areas, right? Some things are not optional. And if anyone even raised their hand, like I'd be like, that's not going to stay like that. So have a think about it. But other things are like very optional. If you don't like Backstage, it's OK. The Spotify people won't come around and argue, right? Like you can use something else. It's fine. So have a think about like the way some of these things are different in this scenario. But the idea here isn't to then stop developers from doing things. It's to provide the policy enforcement inside the platform. So you've agreed this. The developers have said, OK, I understand these, but now I don't have to handcraft these. These are now embedded in these bases, and I have these things ready to use. So this does reduce developer optionality, but it does make their lives easier as well. Like, so it's a sensible trade-off for them.
Yeah, you're doing a good amount of shift down. You have the option to do a lot of shift down. So if type 2 and type 3 are you build it, you run it. Type 4 is you build it, we run it. This is kind of how it works in the large mono repo we have, kind of our biggest developer platform. What you get here is you get the ability to shift down quality attributes into the platform itself, like the ability to take things off of developers' plates. So for example, we have frameworks that we use, and developers don't really need to think about the implementation or risk they're creating for certain classes of vulnerabilities, because we just eliminated the option to make that mistake in the platform. So you don't have to go, oh, did I just create a SQL injection vulnerability? Did I just have cross-site request forgery vulnerability here? No, we've just made it not possible or very, very difficult for those things to happen. This allows us to really create the conditions where developers and development teams can build unfettered. They're freed up from a lot of the constraints and overhead that come from implementing quality attributes. We solve them in the platform. So we get good emergent behaviors with minimal management, minimal process, minimal controls. It takes a lot to build a platform like this, but when you're building at hyper scale, it can become really effective, allowing feature teams to focus on customers and platform teams to focus on the quality attributes.
This is really hard, right? This is a really hard thing to do. So I think we get a lot of requests for it. A lot of customers are very excited about it. They're like, yeah, I want the one that's up and to the right. Of course. Like, of course. What we're trying to explain, I think, a lot of the time is why that's very complicated and why the sort of trade-off that occurs is important to think about in these scenarios. We've also introduced, I think this is something we've had to eat our own dog food on this. Like, increasing number of teams are using cloud within Google, and they're experiencing this and saying, no, I do want type 4. Like, I'm used to type 4, and actually that was good. And so, we're having to do this work ourselves. So we've released some new things here that we released at Next recently, and tried to make that easier for platform teams to build type 4 ecosystems by making it more application-centric, by having the idea that these things don't have to be put in repos with YAML. I know everyone loves YAML. I love YAML, but like, there's too much of it, right? There's way too much. So having those things more as policies, having the policies that you saw in the previous slide embedded into these platform pieces, using these tools to, for you yourself as platform engineers, to then build those things up front into the platform is what we're trying to do. We want to do that in an open way, though. Like, I think a lot of people have tried to do this in very proprietary ways, and that creates a lot of problems as well. So, the core components here you can see hopefully are mostly very open, and we really, I think interoperability is a crucial part for this as well. So think about those sort of pieces to it, and that is accessible, but you'll still need to do a lot of building work to this. We can't actually build a lot of that for you.
Yeah, and I really love how cloud has brought this language and perspective of the application-centric approach, differentiated from a developer-centric approach.
Or the
adding on
centric model. Yeah.
So it solves for like one business model at a time. How many of you have had to, say, deprecate an API in the last couple of years? Last week. Yeah. This is a common challenge that we all have. And this is a good example of having the different tools for the job. We want to have all of this broad range of tools, so we have kind of the right capabilities. So if you think about deprecating an API, at smaller scale, like a method with only a handful of use cases, you're probably pretty good just doing it in your IDE, with the assistance and tools that are there. But let's say you had a method that you found out was used thousands of times. Like, doing it in the IDE is going to become very labor intensive. You're going to have to know a lot of context. It's better to have tools like compiler-based refactoring, something you still want a high degree of precision, and more help. So that's kind of like the increasing scale. Up until what if you have hundreds of thousands of methods to clean up? You need automated tools for hyperscale, or you want automated tools for hyperscale.
We do.
Yeah, and so we do some of this internally, where we have identify usages. We have mechanisms of identifying them. Basically, a developer can just specify the change that needs to be made, and with precision, with safety, with speed, we can go clean all those up. Management doesn't have to have meetings about it. We don't have to get a coordinated effort across thousands of people to make decisions to make that happen. We can do it in a very centralized way. And then we can use it for more than just deprecating APIs. We can use it for many different types of transformations. So, right tool for the job. If you have to change 3 things, you probably don't want the large-scale change infrastructure.
Yeah, so it's a cool story that we've got here. We're like, we just pick these trade-offs, understand them, and your management will understand. Well, this is awkward because, and I'm pretty confident a lot of your sort of senior leaders are saying the same thing. Cool story about trade-offs. I like the idea of adapting and pivoting, but also I don't want to waste time, money, or resources. Like, who does that? So part of this is really explaining that into your leadership, into your teams, to try and explain why some of these things are like this way they are. And thinking about efficiency and effectiveness slightly differently in these spaces. So it's absolutely possible to do some of this. It's just not possible to do all of this all of the time. So pick your battles, I think, in some of these spaces is what we're really saying more, and get better. Get good.
Yeah. And one of the realities of working in this space is as soon as you get good at one thing, as soon as you're successful, you just create new scaling problems, because success creates growth, and then growth creates new limits, new challenges that you're bumping up against. And so this idea of platforms needing to be constantly evolved and improved is often actually a hard one to get across. People think, okay, we've solved this problem, or there was a book about this, or I've achieved this level of process, and now that problem's solved. But it's just like another problem keeps coming up. And so we really need to focus on continuous improvement. And this means, from our internal point of view, we keep trying to understand what quality attributes matter, how we can solve for them, and how we use these tools of abstractions and coupling. I talked about coupling earlier, and we've been trying to explain to leadership, at any given time, why can't we have maximum efficiency and maximum reuse for all new services? That is actually kind of the dream.
Yeah. Slide it to the end.
what we're discovering is that with abstractions and coupling, there's actually different laws of physics associated with them. There's different limits and constraints. And they actually complement each other pretty well. But this is something we actually call Klimek's frontiers internally after Manuel Klimek, who's the engineer that sort of really put their finger on this, which is that when you're using coupling to get the value that you want to get out of your platform, you're going to run into a hard trade-off between the efficiency that you can get from that coupling and how retargetable or reusable that entire platform and ecosystem is to a new business model. This is why you can't take a very vertically integrated, highly coupled, beautifully tuned platform or ecosystem and just plop it in for a new business. Not yet. We have to get way better at abstractions to know exactly what that looks like. But it's very helpful to know when we're reasoning about where we want to be, where we can be, what's possible, to realize that there is this hard trade-off of coupling.
Yeah. And the frontiers are kind of something I think we do really want to just, show people that the trade-offs here are something that you need to really think about very carefully in terms of what you're trying to do. So the temptation here is to say that, oh, well, I can go fast if I go here. It's like, this isn't velocity. You can go fast anywhere, but you can't go fast and efficient, right? The efficiency thing is what's happening here. In those YOLO environments, yeah, you can go quickly, but then when errors occur, problems occur, you can't roll back, you don't have feature flags, all those problems that are occurring, they are fixed in these ecosystems as you go through that, but then suddenly you will have these very fixed ecosystems, and I think that's why we see some things in the industry, and this is more speculation, but why does everything keep drifting to type 2? Why, if we leave stuff, does the entropy of systems, if you're not adding more engineers, your platform is done and no one's looking after it anymore, it drifts back down to type 2 until there's an outage. And then suddenly there's a bit more money and it comes back up from type 1. And so there's a reason why this is sort of pushing our environments to behave in certain ways. You can fight against it, you can push stuff up and assign money, time, or people, but have a think about how these things are working with you or against you in terms of what you're doing.
Yeah, and we talk about the problems to be solved, we talk about quality attributes because we find that as we get better at understanding what we're shooting for here, we can actually move the needle on these trade-offs.
Getting into the takeaways here, right? So what do you do with this? Rethink some of your platform groupings through this lens, right? Think about, do I want one platform that does everything? We don't have one platform that does everything inside Google, and we're pretty good at this stuff. So have a think about, do you actually need to think about breaking up maybe quite a big platform into a couple of different areas that you're focused on, or provide abstraction capabilities that offer different things in those spaces? That doesn't mean split out your platform orgs and suddenly move those into separate sections. You can have the same platform teams looking after that, but have a think about composable platforms a bit more instead of one size fits all. Have a think about how those sections might work for different lines of business for different reasons, whether they do want reusability, whether that's a sensible thing. You might be interested in efficiency all day because your boss is interested in efficiency. Your customer is not, though. Your internal customer is thinking what if next year I need to adopt a new thing or a new feature and it's not possible to do in this ecosystem? That's what's happening with your business line. So think about the challenge in those two pieces and think about maybe doing more composable platforms. Key takeaways, I'm not going to read these out to you, right? But you've seen these through the talk. Have a think about these pieces as you're going through designing and building your platforms. Big shout out to the Dora team, some of the Dora folks here, and I help them as well. So one of the big lessons of DevOps, and I love this one, and we talk about this all the time, is get better at getting better. So actually, trying to design the perfect platform has been an anti-pattern for a lot of us, right? Just give me the golden scroll of platforms, the one true platform that we can build and we'll fix all these problems. And we're actually, no, what we've learned is there is no one size fits all, but also if you're really good at building platforms, then you're really good at being able to build these different types of ecosystems. You'll be able to, to instantiate those much quicker. So you're actually better off at improving your understanding, refining and adapting your capabilities in these spaces. So focus on those and then have a think about shift down.
Yes. So as a software system grows, if you're successful in supporting software development, the need for both feature and platform development increases. And this is the fundamental challenge of scale. And this is kind of why, whether we have a small scale system or a really large scale system, we basically have the same problems and we basically have the same needs. And there's these tensions between feature and platform that can really kind of be our guide. If you can notice where you're having problems and where those hard trade-offs are, yes, they're problems, but yes, that's also where you find out where your opportunity is. So, shift down. It's the way that we have developed, I guess, a language that can be shared across a community within Google and hopefully, for Google Cloud customers and the broader community as well.
Or not. We're engineers, we're not cops. If you don't want it.
We hope you find it useful as well. And with that.
So we got a bit of time for questions at the end. No questions is fine, right? Like there's a bar here, but like there's probably some questions. So do we have some mics?
Yes, I have a mic right here.
You
there are
have
a lot of
the
hands
mic
raised.
power.
So Leah, you pick who's going to go first.
Oh, well, that's the first one I saw. So.
Okay. I'm jogging to you.
The mic power.
But maybe some.
Hi, I'm Javier. I thought this framework, was it Climax?
Oh, the Climax Frontiers?
The Climax Frontiers was very interesting. As a concrete example, I'm curious if you can share when you take, say, a Type 4 system that's been successful at Google, a platform that's working well internally, and you think of sharing it with the broader GCP customer base. Do you see that translating as a new Type 4 platform, or do you see it slide down in this curve?
I think to really make that Type 4 vertically integrated, super tuned mechanism retargetable to a lot of different business models, we have to get better at abstractions. Getting better at abstractions is slower than getting better, at coupling. Coupling, we can just baling wire and shoestring and pull things together and kind of have it work. And so I think that that's something that Climax Frontiers has kind of forced me to see, is that abstractions are the way that we get out of this constraint, and we can do both. So, in our partnership with Google Cloud, it's like, okay, can we articulate the business model that this is actually tuned for? How do we put these abstractions together in a way that is meaningfully modular and composable and reusable, so we can pass that goodness on?
Even the framing of this is super important, because I think we have bets internally who are like, hey, I want to spin out. I don't want to be on the Type 4. And then when they're off the Type 4, they're like, but I liked some of the bits. so maybe I do want my own Type 4, but also cheaper and reusable. So that conversation is still not happening. We're still surfacing some of these concepts, because for some engineers, it's just never really come up. They're like, well, just build it better. So just talking about it, I think, has been enlightening.
Yeah, and it reminds me, I think it was Dijkstra that said premature optimization is the root of all evil, right? That's kind of we don't want to jump to a Type 4. We might mire the whole organization in broccoli problems. I don't know if that term is going to land either.
We'll try.
But and so we can only use the resources available today, and breaking this has everything to do with getting better at abstractions and really understanding the problems we're solving.
We got two here. We'll try. We'll do it. Come on. All right. We'll do. You sat at the front. You sat at the front.
You mentioned shadow IT and shadow AI IT, basically. I'm curious how the introduction of AI coding tools, including Google's Agent and CLI that shipped yesterday, are going to affect this, with the ability of AI to encourage or enforce platform standards and policies, as well as the ability to YOLO a lot of slop.
Yeah, and I think there's a couple of pieces to deconstruct from that, basically. I think one is, a lot of people have been opining on how AI is going to impact things in the future. And if they do know about the future, I have a separate question for them. Right? I would also like to know less about the AI and more about how you're predicting the future. I'd love to know that. So I think we don't aim to predict the future itself. I think what we've spent a lot of time doing is thinking which parts of the platforms will probably want to stay the same, which parts might not be needed in these scenarios with AI usage for various pieces. And I think what we found, and I'm generalizing here, right, but I think what we've generally found is we actually need more platform a lot of the time. Like, it's actually reinforced the need by having more agentic AI usage, by having more non-deterministic activities occurring in our ecosystems. Policies have become more important. People are saying, I really want to do this, but I also need to know that the guardrails are in place. The security team isn't happy about just letting stuff go. They're like, oh, it's AI, you're good. That's not how it's going. So we've still got that conversation, I think, where we're not really fundamentally redesigning a lot of our platforms in this space, but we are definitely seeing a much increased need for all of the items that we've really talked about today. And I think that will be something for a lot of platform teams to think about is, how do I cope with the fact that before I could do this manually, and now there's 100 agents? You probably should think about a policy. Like, that's what we do. Like, ever think about doing it policy-based in that space? So I do think there'll be other unexpected occurrences, but that's kind of, I think, some of our current thinking in some of these pieces. I don't know if you have some.
Yeah, I mean, I think like doing AI well requires doing platforms well in a meaningful way. And we've tried to share some of the things that we found most useful here that we actually, so far, think are stable concepts, things that we can keep focusing on. And I think about like when I first started building at another cloud place back in like 2012.
Could be anywhere.
We had challenges. We did a lot of research. There's like back in 2012, there were 3 fundamental challenges to being successful adopting, cloud services. What resources do I use? How do I safely and effectively combine them? And how do I estimate cost? Those keep getting harder. I'm really excited about what capabilities open up our ability as an industry to solve those problems internally at Google and externally by using it. It's like, that's probably the only path forward for us to really kind of deal with the complexity and that we're dealing with just the vast variety of possibilities.
We've been running ML models, I think, in Google for a very long time.
Yeah.
Right? That's something where, at scale, right? A lot of ML models for, and there's some AI stuff which is very, they're not just talking ads, right? The Waymo teams are pretty good. Like, it's something that, again, like I think is important to consider that AI means a lot of things in these spaces, but those fundamentals don't necessarily change. That makes sense? I mean, we got.
Thank you.
Thank you. One more. I'm going to keep going, but everyone wants a question here. This is exciting.
I think I have the question on the same slide. How the LLM-assisted development will change the reusability?
Change the reusability.
So because multiple business teams, multiple teams are developing, then how this is reusability will impact on that?
Have you got the slide? Can we go back to the one with the ecosystem example? Hold on, we'll go back.
The map?
Just a few more. No, one more. There we go.
Oh.
Oh.
All right.
So help me on clarifying, like, where exactly are you thinking?
On the continuous global compiler refactoring.
Okay.
Right. So if let's say I'm moving from a legacy app to refactoring it, right?
Okay.
So the platform engineering model, how the reusability of the code with the LLM assisted would help.
Oh, yeah. First of all, to clarify on the.
You had one more slide to explain that, actually. So I don't know which slide it is.
Okay, so reusability and retargetability of the platform and ecosystem itself. So hopefully we have tons of reusable components within their libraries, APIs, search services. And so, but I think the challenge is how much control do you have over the emergent properties? How much can your platform influence the non-deterministic things that happen? And that's really where you look. These types can be helpful in whether you're using agents or not. Who is responsible for the quality, the safety of that outcome? and how can you make that easier? So
there's some natural boundaries for that, I think, as well. I think we've seen like a lot of people thinking about like things like MCP servers now as that sort of boundary of when does it become the platform problem, like whoever's hosting or beneath the MCP server, and when's it the developer problem? It's whatever you're throwing in at the front end, right, the client. So we still think the reusability bit here is below the glass in that, right? Like that's the bit that we're talking about when we mean reusability. Like the consumption at the top is still dependent on your ecosystem choice. That's not really changing the platform piece. There's obviously wider implications for the SDLC. Does that make sense? Sort of. Further questions?
We might have time for one more.
Sneaky.
right down the row.
Hey,
This is a cool row. I think you guys. All right, this guy at the back's got an opportunity to do the funniest thing.
All right, James Leah, thank you so much. I'm curious, at Google these days, are the signals dialed in so much that you kind of, a VP looks year after year and says, okay, Dora, efficiency, time to live here, we're gonna invest in platform here. Or another team says, actually, like we're kind of maybe over dialed, and so next year we're gonna shift more towards type 2, so there's more agency or whatever. Is that kind of how decisions get made? Because, and the reason I'm asking is because I'm wondering how to pitch this to my leadership to say, like, what are the signals I need to dial in on? Is it MTTR? Is it like, all the stuff that we talk about out there? So yeah, what's the decision criteria that you and your leadership, team uses to determine the dial up, dial down? Is it just Dora? Is it, let's be pedantic, is it like we're spending too much manual time for developers here, and so we want to automate some of that? I'm just curious.
I'll put you on the spot for this one.
Yeah, well, I work across a lot of different product areas, and so there's a lot of different answers to that question. I know that's like, but one of the things that I think, the reason we showed the map is because it can be very useful to go through some version of that with your leadership team and identify where the biggest risks are. Taking a risk-driven approach to your platform investments, opens up dialogue and actually helps you connect the dots from, how risky is it? Like, you can't just talk about security overall. There's certain aspects of security or certain aspects of compliance that are really load-bearing for your business. And so that shared understanding and finding, that's the map that we found useful. It's based on a lot of work that Mary Shaw from Carnegie Mellon has done. But pick the thing that drives that shared understanding around those. So that's the social piece of it, is really just appreciating like where is the biggest risk and what architectural or ecosystem things might we be able to do, what shared responsibility things might help. That's one piece of it. The other piece is how do we measure? Dora is a really good start. One of the great things that I love about what Dora does, in addition to this ethos of getting better, is that it brings the focus to the unit of shippable value. So you're not looking at like broad aggregates across a whole org, like, oh, our velocity is going up or down. What do you do about that? Well, that's where the rubber meets the road, so to speak, is in this shippable unit of value. There's a larger paper if you want to read a slightly longer, dense paper that we just put out. I think it's on ACMQ, called Develop, Deploy, Operate, the DDO paper. And this was my and a couple colleagues' attempt to lay out general things you can know about measuring effectiveness of your platform that can help. So for example, the development phase of any workflow, no matter how the workflow is set up, is distinctly different than the deployment phase. Deployment phase is where like factory metaphors apply, and you could look at a feature developer's time spent in deployment as overhead. Any reduction that you have in that overhead that you can take away from that and reinvest it into development, for example, is a really high leverage ROI. Even if you can't measure it like in really clean, specific numbers, but having those rules of thumbs, and hopefully this paper can be used as like a backup, like this, reference that paper type thing, those are some things I find helpful.
And just super quickly on that, I think from conversations I have with customers, right, in that. So sometimes leadership wants to hear the theory. Now you've got some. Sometimes they don't, right? So sometimes we boil down to a couple of things. Often they prefer to make the decision if you give it to them. So sometimes just giving them the decisions is actually powerful. Previously, their engineering teams are like, it's complex and you wouldn't understand. I'm like, right. Okay, but that means you're taking a bit of a gamble in that space. So sometimes just using the terminology, developing the terminology, and having a conversation, just put it, do you want this or do you want that, like, is actually constructive. And I would encourage that does happen. And I think the second piece as well, like, you'll often find tentpole quality attributes. Like some companies will be lasered in on security or lasered in on reliability, and those will drag up the rest of the ecosystem, right? I have a lot of platform teams, like, my biggest sort of hot tip to people in platform teams are like, I'm always short of money. Every platform team is short of money. It's like a common problem. I'm like, your security folks have money. Go ask them if they've got security problems that can be solved by platforms. Answer, yes, you do. Take that security money. Do not be shy. So that tentpole for security, for instance, will pull up all of the other activities. You don't need to start talking about performance or latency if the security team have cash. That's fixed itself, right? So think about maybe some of those tentpole things rather than ticking every box in those pieces. Hope that's somewhat helpful. How are we doing for time, folks?
I think we're right about time.
So yeah, a big thank you. We'll be at the booth if people want to answer further questions. And thank you so much for your time.
Thank you.